So here the model is given in the form of a taper bar with a uniform thickness. Let us say that thickness is 10 mm is given for this bar. Okay, so the thickness, it means it is a plate like this. Okay, one end is larger area, another end is smaller one, and there is a one uniform thickness, that is as 10 mm here mentioned, and this width will be 800 is mentioned here, and 40 mm is the another end. Here is 40 millimeter. All dimensions are in millimeter. Okay, so it looks like this. When you see from the another view, it will appears like this, but in the front view it will be like a circular bar, but it's not circular because in the question the thickness is mentioned. Okay, if there is no thickness, then it will be generally a circular bar. So thickness is mentioned, it means it's having a plate. So this uniform taper bar, we have to model into equivalent stepped bar. Okay, because in many of the finite elements problem, we cannot solve this taper bar. It's very difficult, highly difficult. So hence we can simplify this into stepped bar. Okay, so what is the procedure to convert from this taper bar into stepped bar? That I am going to cover in this video. Only converting from taper bar to stepped bar. Okay, so first you need to find the area of this one end and area of the another end. Let us divide this into, for example, if I take an, here it will be node 1 and here it will be node 2, here it will be node 3. So elements, say this is element 1 and this is element 2. So we divided this taper section into two parts, one element and two elements, and three nodes, 1, 2 and 3, where 2 will be appeared at the middle of this taper bar. Okay, because the total length of the bar is given as 300 and where at the midpoint is 150 mm. Okay, so that will be the midpoint having node 2, and these sections are converted into finite element model like a stepped bar. We have to convert. Okay, so all dimensions are in millimeter, remember. Now first we have to calculate the for the taper bar. Here I will mention for taper bar. Okay, for taper bar only I am considering this. What will be the area at node 1? Say A1, area at the node 1 here. So it is 800, one distance is 800 and into the thickness 800 into T. So it will be, sorry, it is 80 not 800, it is, let us make it is as 80 here, it is 80 only. Okay, so 80 into 40, sorry, we are calculating the area for node 1, right? So 80 into 10, so it is 800 millimeter square area, and area at the node 3, because we don't know what is the area at node 2. Okay, here we cannot calculate what will be the distance here. So first we will calculate the area at 3, that is A3. So there 40 into 10, so it will be 400 millimeter square area at 3. Now we can calculate the area at 2 by making the average of 193. So it is A1 plus A3 by 2. So 400 plus 800, so 1200 by 2. So it will 600 millimeter square. So here the area at node 2 is 600, the average of 193 that we can calculate. So for taper bar we have got the area at all the nodes 1, 2, 3. Okay, now we'll go for for stepped bar. Okay, so let us assume the stepped bar will be converted like this. Now here again it will be same, like node 1 at the midpoint there will be node 2, and here there will be node 3. Okay, so what will be the area at the node 1, or what will be the cross section area, because it's a now it is what it is a uniform cross section area, it is not a taper. Now we have to calculate the area for this entire element. Okay, what is the entire element? Let us say this is element 1, this is element 2. So here the area for A2. So what will be the area at section 1 or element 1, we can say A1. A1 will be the area for this element. So first we should know the area at the node 1, and we should know the area at the node 2 for the taper section. So area at node 1 is 800 plus area at node 2 here, because we are making these two as a uniform. So area 1 and area 2, that is 600. 800 plus 600 again by 2. So it will be 1400 by 2. So we got 700 millimeter square is the area here. It is 700. Okay, it means this distance. Okay, because again it is a plate. Okay, it is not a circular cross section, it's again plate. Okay, as I am saying that it's like this. No, just in the front view you looks like a circular cross section, but when you see the another view, so it's a plate, means we got the area for this as 700. It means this width is 70 and thickness is 10. Okay, so here width is 700 and of course the thickness will be 10 mm. So 7 into 10, it becomes 700. Okay, but in the model it's looking like a circular cross sections. Okay, that we have to very carefully. Now area for element 2. So for element 2, the area at node 2 and area at the node, these two elements are the connectivity for 2. So 2 and 3. Area at 2 is 600, area at 3 is 400. So 1000 divided by 2. 600 plus area at 2 and area at 3 400. So it is 1000 by 2. So it's 500 millimeter square. It means here the area of cross section is 500. So for 500, this width is 50 for the another stepped bar and the thickness is 10. Okay, so first this is 70. Next for the another element it is 50. Okay, so width is 50 and thickness is 10 for this. Hope you got this right. So thank you for watching video. Have a good day.